Hi students, today we are going to learn Brewster's law in polarization of light. The mathematical expression for Brewster's law is tan IP is equal to N. So the tangent value of the angle of polarization is numerically equal to the refractive index of a medium. So here what is our intention is to derive this Brewster's law. So Brewster performed the experiment to derive this expression tan IP is equal to N. How? Let us see now. So let us assume XY is a glass sheet. It is the reflecting medium. Okay. So ordinary light, namely unpolarized light, is allowed to be incident on the glass sheet. What will happen when a ray of light will be incident on the glass sheet? Partially it will undergo reflection. Partially it will undergo refraction. So I have shown in this picture, XY is the reflecting surface which is made up of glass, and different incident rays I have shown 1, 2, 3. So initially when a ray of light is incident, okay, when a ray of light is incident at this angle, okay, a corresponding reflected ray and one refracted ray will be available. So this is the corresponding refracted ray. So for the first incident ray, you can see a reflected ray. Okay, so this is the first reflected ray and this is the first refracted ray. Now, Brewster took a tourmaline crystal and he placed on the path of the reflected ray 1. And he rotated the tourmaline crystal and he found that there was the change in intensity, and he proved that the first reflected ray was partially polarized. Similarly, when he kept the tourmaline crystal on the path of the refracted beam of light and he rotated, here also there was a variation in the intensity, and he proved that the first refracted ray was also partially polarized. Next, slowly he increased the angle of incidence. So you can see the second incident ray. For the second incident ray, the angle of incidence is now greater than that of the first incident ray. So the second incident ray, corresponding to that, there was a second reflected ray and a second refracted ray. So whenever the angle of incidence increases, corresponding angle of refraction also increases. Again he repeated the same. By placing the tourmaline crystal, he rotated the crystal and he measured the intensity of the light reflected and refracted. He found that again they were partially polarized. Like this, when he repeated by taking the other reflected rays, he analyzed the reflected rays and the refracted rays corresponding to the third incident ray. So like this, every time when he analyzed by using a tourmaline crystal only for one particular angle of incidence, he found that the reflected ray was completely plane polarized, 100% polarized. Whereas for the same angle of incidence, now also the refracted ray was not completely polarized. It was still partially polarized. And he called that particular angle of incidence as angle of polarization. That only is denoted with the symbol IP. Understand? So, what are all the important factors to be remembered at the polarizing angle? This is angle of polarization or a polarizing angle for the given medium, namely glass. Polarizing angle for glass is denoted by the symbol IP. What is the speciality at this IP? There are two specialities. One is, at this angle of incidence, the reflected ray is 100% polarized. Second point is, at this angle of incidence, the reflected beam and the refracted beam were perpendicular to each other. So what are the 2 points I said? at the angle of polarization. First one is the reflected beam is completely polarized. Second one, what we said, the reflected beam and refracted beam both are perpendicular to each other. Okay. So, how do you define polarizing angle first of all? How do you define polarizing angle? Polarizing angle is defined as the angle of incidence. So, it is the angle of incidence at which, at which the reflected beam, at which the reflected beam and refracted beam are perpendicular to each other. Refracted beam, are perpendicular to each other. Also, at this angle IP, the reflected beam, the reflected beam is completely polarized. Okay. So, what is the principle by which this Brewster's law can be proved is polarization by reflection. So, I am writing the principle also. It is based on polarization by reflection. Okay. Now, the actual diagram required in the examination, I have not drawn still. I am going to draw in your presence. We have to draw a picture such that the refracted beam and the reflected beam are perpendicular to each other. Exactly, if you want to draw the diagram, means my advice to everyone is first you draw the refracted beam. Understand? Don't draw the incident beam first. Now look at the board. I am going to draw the picture corresponding to Brewster's law. So, what is the diagram required in the examination? I am going to draw now. So, you have to take a scale and you have to draw a straight line corresponding to the refracted beam first. See here, I am drawing the refracted beam. Understand? So, this is the refracted beam. Okay. Why I am drawing this first? This is because I have to draw another straight line perpendicular to this refracted beam. Is it not? So that so perpendicular to this 90 degree, 90 degree like this, perpendicular to this, I am drawing the reflected beam. So this is the reflected beam. You see here, this beam is reflected. This is a reflected beam, and this one is what? Refracted beam. Refracted beam. Now it is very clear that these two are perpendicular to each other. Is it not? Then, if this is the angle of reflection corresponding to or equal to this side, we can draw another reflected ray. So, corresponding to this, the reflected ray can be drawn like this, so that the picture will be perfectly correct. Understand? You see here. So, this is the incident beam. So, the incident beam is having vibrations in all the directions. Why? Because it is unpolarized light. So, this is unpolarized light. And here, this reflected beam is perfectly polarized. So, we can represent the polarized beam diagrammatically by two ways. One is only by the dot components. The other one is only by the arrowhead components. But now you should be very careful that these components present in the reflected beam, these components are the dot components. Dot components are what? They are perpendicular to the reflecting surface like this. Understand? So, these components must be dot components. And the other ray, namely the refracted beam, it consists of both dot components as well as arrowhead components alternatively. So, this type of diagrammatic representation is what? Partially polarized. Understand? So, this is 100% polarized. Reflected beam is 100% polarized, and refracted beam is partially polarized. Okay, now what is the angle of incidence corresponding to this position, this angle? This is IP, and the angle of reflection also is equal to the angle of incidence. So this angle also is what? IP, and this is 90 degree. Okay, this is 90 degree, and this angle is R suffix P. P is the suffix because this is the angle of refraction corresponding to the polarizing angle. Understand? Okay, now in this picture, what are all the informations we have to convey? We have to convey what are all the informations you see. Angle of incidence is equal to the angle of reflection, that is angle of polarization. This is the polarizing angle for glass, IP. Corresponding angle of refraction is RP. And the angle between the reflected beam and the refracted beam is 90 degree. Understand? So, I will write at polarizing angle. At polarizing angle. If you add the total, okay, total angle, okay, that is IP plus 90 plus RP. IP plus 90 plus RP. The total angle should be equal to that of a straight line. Straight line, okay, N dash, okay. If you call this point as O, means it is NO, N dash. Understand? So, this total angle must be equal to 180 degree, and this 90 is subtracted from 180 on the right hand side, so that IP plus RP. So, IP plus RP is equal to 180 minus 90, and that is equal to 90. Therefore, RP must be equal to 90 minus IP. So, this is one equation. So, the angle of refraction is equal to 90 minus angle of polarization or angle of incidence. Now, from Snell's law, okay, from Snell's law of refraction, sine of the angle of incidence divided by sine of the angle of refraction RP must be equal to the refractive index of the medium, that is glass, that is equal to N. So, this is again rewritten as sine IP divided by this RP is equal to 90 minus IP. Therefore, I am writing sine of 90 minus IP. So, this is equal to N. Now, sine of 90 minus theta is equal to cos theta. Is it not? So, sine of 90 minus IP is equal to what? Cos IP. Okay, I am going to write this again. So, sine IP divided by cos IP is equal to N. Okay. Therefore, what is sine theta by cos theta is equal to tan theta. Understand that? Therefore, okay, we can write the same expression like this. Tangent value of IP is equal to N. So, this is equation 2, and the final equation, this is equation 3. So, this is what we are required to derive. So, the tan IP is equal to N. So, you have to write the statement in words. So, how to write in words? The tangent value of the angle of polarization is numerically equal to the refractive index of the medium. Understand? Now, using this in competitive exams, numerical problems will be asked, or in the board exams also the problem will be asked. So, one example, let us solve here itself. So, find the angle of polarization. Find the angle of polarization, okay, for a medium, having refractive index is equal to square root of 3, or they may give in values 1.732. Like this they may give. Okay. So from Brewster's law we can determine the value. Tan IP is equal to n. So tan IP is equal to root 3. Therefore IP is equal to tan inverse of, okay, tan inverse of square root of 3. So we have studied tan 0 is 0, tan 30 is 1 by root 3, tan 45 is 1 and tan 60 is root 3. Okay, tan 90 is infinity. Like that we have studied. So you have to remember those values. So for which angle the tangent value becomes root 3 is a 60 degree. Therefore IP is tan inverse of root 3 or, okay, or IP is equal to 60 degree. This is how to solve the numerical problems using Brewster's law. Okay students, what is the statement of Brewster's law once again? The tangent value of the angle of polarization is numerically equal to the refractive index of a medium. Okay, what is the polarizing angle? Polarizing angle is defined as the angle of incidence at which the reflected ray is completely plane polarized and also the reflected beam is perpendicular to the refracted beam, and it is based on the principle of polarization by reflection. I hope you have understood well. Fine.